Booster 21 just turned completely white, frozen solid, loaded with nearly full propellant. This single test decides if a booster survives an actual launch countdown, and SpaceX just watched it pass. 2 tanks, full cryogenic pressure, 0 failures. While Flight 13 sits grounded after 2 back-to-back aborts, Flight 14's booster just cleared the one test that matters most. Here's exactly what SpaceX confirmed. Let's rewind 7 days. July 16th, Starbase, Texas. Starship Flight 13 sits on the pad. The countdown clock ticks towards 0. 33 Raptor engines prepare to ignite beneath Booster 20. This is the moment everyone's been waiting for. The clock hits 0. Engines fire. The water deluge system floods the pad with thousands of gallons per second, exactly as designed. Then silence. No liftoff. No plume climbing into the Texas sky. Just a rocket, sitting still, engines cutting out almost as fast as they started. Onboard computers made the call in a fraction of a second. Something was wrong. And the system did exactly what it was built to do. It stopped. 4 days later, a different coast. Vandenberg Space Force Base, California. This time, it's not Starship. It's Falcon 9, the most flown orbital rocket in history, carrying another batch of Starlink satellites. Falcon 9 doesn't abort. Not like this. Not after more than 600 successful booster landings, and not after over a decade without a single in-flight mission failure. But on July 20th, it did. Engines ignited. And at T0, the exact same moment Starship failed 4 days earlier, Falcon 9 shut down too. SpaceX's statement was short. Standing down from today's Starlink launch. Vehicle and payload remain safe. 2 completely different rockets, different engines, different fuel, different teams, different launch sites, 1,800 miles apart. Built on different philosophies, at different stages of maturity. And yet, both stopped at the exact same phase of their countdown, within 96 hours of each other. That's not a detail people can ignore. That's the kind of coincidence that makes engineers nervous. The investigation. Coincidence or something deeper? The question everyone is asking right now, is there a hidden thread connecting these 2 failures? A shared supplier? A software update pushed across both programs? A ground systems issue affecting SpaceX's broader launch infrastructure? It's a fair question. SpaceX doesn't run Starship and Falcon 9 in isolation. Both programs share personnel, share testing philosophy, and in some cases, share suppliers for raw materials and components. If one supplier shipped a bad batch of something as simple as a sensor or a valve seal, it's not impossible for that flaw to show up in 2 unrelated vehicles. But the evidence points a different direction. Falcon 9 has now flown more than 650 missions, with a success rate above 99%. When a vehicle with that track record suddenly aborts, engineers don't panic. They trust the process. An abort at T0 means the flight computer caught something outside acceptable limits, whether that's a pressure reading, a temperature sensor, or a valve responding a fraction of a second slower than expected. The system worked exactly as intended. It just worked at the worst possible moment for public perception. And the response speed backs that up. Falcon 9 targeted another launch attempt within roughly 24 hours of the abort. That's not the behavior of a company staring down a systemic, fleet-wide problem. A deep investigation into shared hardware grounds a rocket for weeks, not a single day. Whatever tripped this abort was localized, caught, understood, resolved. Starship is a different story entirely, and that's where this gets more serious. When Elon Musk first commented on the Flight 13 abort, the number floating around was 2 engines. 2 faulty Raptors, swapped out, problem solved. Simple story, except that may not be the full picture. Independent observations from around the Starbase perimeter suggest 4 engines, not 2, failed to ignite properly during that countdown. Worth being precise here, this figure comes from unofficial observations, not a confirmed statement from SpaceX. Treat it as the most credible estimate currently available, not a verified fact. If accurate, though, it changes the story considerably. 33 Raptors are supposed to behave like a synchronized orchestra, each one hitting ignition within milliseconds of the others. 4 missing their cue at once isn't 4 isolated bad parts. That's a pattern. And patterns demand investigation, not a quick swap. That would also explain why both stages didn't just get 2 new engines and roll back to the pad. They rolled all the way back to the production site. Full inspection, reportedly extending even to the 29 Raptors that fired exactly as intended. When a rocket shows a pattern like this, engineers don't just fix what broke, they check everything that didn't, because next time it might. That's likely the real reason Flight 13 is taking longer to return to the pad than a simple two-engine swap would require. What happens next? Reading the road closure. A road closure notice near Starbase, running from 9 a.m. to 11 p.m. on July 22nd, just appeared. In SpaceX's world, road closures aren't administrative paperwork. They're a signal that something significant is about to happen on that pad. Two realistic possibilities, and each tells a different story about how confident SpaceX is right now. Possibility 1. Another static fire. Booster 20 returns to the pad alone, gets loaded with propellant, and fires all 33 engines again under full power for several seconds. Given the ignition issue, repeating this test is common sense, not overkill. Engineers would watch thrust curves, chamber pressures, vibration data, and ignition timing on every engine, hunting for the smallest deviation from normal. If this happens, the upper stage, S40, has to roll away first. A full static fire generates enough heat and acoustic energy that nothing can safely sit above it. Possibility 2. A wet dress rehearsal. The quieter option. Both stages get stacked, fully fueled, and walked almost all the way through the countdown. Everything except ignition. It's a systems check. Fueling procedures, countdown software, communications, timing, all tested under real conditions, without putting additional stress on engines that already showed a problem. Think of it this way. A static fire is a full-effort sprint that goes nowhere, testing the engines directly. A wet dress rehearsal is a walkthrough of race day itself, testing everything around the engines instead. Both buy confidence, both cost time. Given that the ignition problem points at the engine specifically, the smarter bet leans toward another static fire. SpaceX doesn't usually walk away from a flagged component without retesting it directly. There's a deeper tension worth noting here. SpaceX is being extremely deliberate with Flight 13. Normally, that kind of deliberation on one program slows progress everywhere else at the company. Except that's not what's happening. While Flight 13 sits grounded, undergoing what looks like its second full review in a matter of days, something remarkable has been happening in a completely different corner of the operation. The Milestone. Booster 21 just turned white. While Flight 13 gets picked apart engine by engine, Booster 21, the vehicle slated for Flight 14, has been quietly running its own test sequence at the Massey's site, and it just cleared the hardest one. B21 arrived at Massey's on July 17th. First, a structural test, checking the airframe can handle mechanical loads with no propellant on board. Then 2 smaller cryogenic tests over the following 2 days, brief exposures to super cold propellant designed to check individual systems rather than push the whole vehicle to its limits. Then came the test that actually matters. On the 3rd attempt, SpaceX loaded both propellant tanks to nearly full capacity, liquid methane and liquid oxygen, both cold enough to make steel behave differently than it does at room temperature. The result? The entire booster turning white, coated in frost from nose to base, as ambient humidity froze solid against the super-chilled hull. This is called a full Frosty test, and it's arguably the most demanding checkpoint in Starship's pre-flight sequence. A structural test checks if a bridge can hold weight. A small cryogenic test checks if individual bolts handle cold. A full Frosty test is the equivalent of driving a fully loaded truck across that bridge in a snowstorm at rush hour, the closest simulation of real launch day conditions SpaceX can run without lighting the engines. Every tank, weld, plumbing junction, and structural joint gets hit simultaneously with the same thermal stress it would face minutes before an actual launch. Booster 21 passed. Detanking completed successfully afterward, the clearest signal the vehicle handled the test as designed, with no structural surprises and nothing forcing an early shutdown. Put the 2 boosters side by side. One, an ignition issue serious enough to send it back to the factory floor. The other, a full-load thermal stress test cleared without incident. Same company, same 7-day window, 2 very different outcomes. That contrast is the actual story most coverage is missing. While one program hits a wall, the next vehicle in line is already clearing hurdles ahead of schedule. What comes after B21, the path to Flight 14? B21 won't stay at Massey's much longer. With cryogenic testing complete, it heads back to the production site for inspection, engine installation, and eventually its own static fire. The same test Booster 20 is likely about to repeat for Flight 13. This is the detail that reveals how tightly SpaceX is running its production line right now. The moment B21 clears out of Massey's, it frees up testing space for the next piece of hardware in the queue. Ship 41, the upper stage for Flight 14. Engine installation on S-41 has reportedly been underway for weeks, quietly, while public attention stayed locked on Flight 13's abort drama. With B21 nearly finished at the test site, S-41 can now begin its own major test campaign, potentially including its own static fire before the month is out. Put those two data points together, B21 heading toward integration, S-41 beginning its own critical testing, and a picture forms. Flight 14 hardware isn't just progressing. It's on a timeline that could realistically put a launch attempt in August. That timing matters more than it might seem. SpaceX President Gwynne Shotwell has talked publicly about the company's ambition to reach a monthly Starship launch cadence, something no vehicle of this scale has ever achieved. If Flight 14 lines up for August while Flight 13 is still working through its own delays, that's not just one rocket flying. That's the first real glimpse of two Starships moving through the pipeline on overlapping, near-parallel schedules. That's the real milestone this update delivers. Not just a Frosty booster, a production system starting to behave like the assembly line SpaceX has always said it wants to build. The problem that doesn't go away. While all of this unfolds on the ground, a separate announcement landed this week that connects directly to how millions of people will actually experience the return to the moon. NASA confirmed that Artemis 3, the mission carrying astronauts back to the lunar surface for the first time since Apollo, will rely on SpaceX's Starlink mini laser communication terminals mounted directly onto the exterior of the Orion spacecraft. The significance is simple to explain. Traditional spacecraft communication relies on radio waves, the same basic technology used for decades. Radio works, but it's limited in how much data it can push through space at once. Laser communication, or optical communication, works differently. It uses focused beams of infrared light to transmit data, and light-based systems carry dramatically more information per second than radio ever could. Picture the difference between mailing a letter and streaming a live video call. That's roughly the gap between old-school radio telemetry and the optical crosslink technology already running across SpaceX's Starlink constellation in low Earth orbit. Go back to Apollo for a second, since that's the comparison most people naturally reach for. The footage beamed back from the lunar surface in 1969 was grainy, low frame rate, mostly black and white. That wasn't a creative choice. It was the hard technical ceiling of what radio bandwidth allowed across roughly 238,000 miles of space. More than 50 years later, laser communication pushes that ceiling much further out. The bottleneck stops being the distance to the moon. It becomes simply how much hardware NASA chooses to fly. Two of these terminals will sit on Orion's exterior for Artemis 3. NASA's stated goal is 4K video, streamed from lunar distance, straight to mission control in Houston. Not scratchy black and white transmissions like the Apollo era, but real high-resolution footage of astronauts stepping onto the moon, delivered close to real time. This isn't SpaceX's first appearance in this part of the Artemis program either. During preparations for Artemis 2, NASA already tested optical communication hardware capable of handling high-definition video, scientific data, engineering telemetry, photographs, and voice all at once over the same laser link. Artemis 3 builds that proven system directly into the mission architecture. There's a bigger pattern worth sitting with. Starlink was originally built to sell internet access to homes and businesses on Earth. Today, it supports private astronaut missions like Polaris Dawn and Fram 2. It helps coordinate Starship's own test flights. And now it's about to carry humanity's return to the moon in high definition, live, back to Houston. Between building the rocket, building the lunar lander, and now building the communication system astronauts will use to talk to Earth, SpaceX isn't just one contractor among many on Artemis 3 anymore. It's becoming the backbone, running underneath nearly every layer of the mission. 3 storylines, 2 grounded rockets under investigation, 1 booster that just cleared the hardest test in its development cycle, 1 NASA announcement quietly redefining what watching a moon landing is going to look like in the years ahead. On the surface, this looks like a rough stretch for SpaceX. Underneath it, the data tells a very different story. 2 boosters, 1 clear data point this week. Thanks for breaking it down with me. I'm Adrian, the Space Brief. Like, share, comment, subscribe, and check the screen right there for what's next.